Okay, in this lesson, we are going to show you how to connect ammeter to a circuit. Ammeter is a measuring device to measure and monitor parts of the circuit. So it looks something like this, and the circuit symbol is just a circle and an A. Ammeter measures the current flowing through its path. So whenever a current flows through, the ammeter measures the current flowing through its path. However, it is not part of the circuit, and your circuit will work with or without the ammeter. So generally, if you have a circuit like this, you don't need to include the ammeter. Okay, but of course, if you want to find out what is the current that's flowing in this particular resistance, you have to insert an ammeter over here. And how do we connect the ammeter? That's what we are going to explore this lesson. So how do we connect ammeters? Generally, ammeter is connected in series with the measured component. In other words, one after another, or is right on the same path. So imagine that you have a light bulb that's over here and the current flows from the battery to the light bulb. So if you want to find out what's the current, and you just connect ammeter in series, one after the other. So just look at this. Okay, the current will flow through the ammeter, will flow through the light bulb and go back to the battery. So that is the current that's flowing through, and the ammeter actually measures that. Alternatively, you can also place your ammeter behind the light bulb. So again, the current flowing through to the battery, to the light bulb, and then to the ammeter will be the current that the ammeter measures. A common student misconception about current is that after a current flows through a component, in this case a light bulb, the current will be lesser than before. But this is incorrect. As you can see from the simulation, the current before and after the light bulb is the same. One simple way to visualize this is to think in terms of the water flowing in and out of the tank. In order to have a smooth flow of a water current, if the rate of water flow is 1 liter per second, the rate of the water flowing out must be 1 liter per second. It is because if the water flowing out is less than flowing in, for example 0.9 liters per second, there will be water accumulating in the tank and eventually it would burst. It is also not possible to have more, as you cannot have more water flowing out than flowing in. It is like having a total of 100 people going into the hall and at the end 200 people coming out of the hall. So in order for you to have a smooth flow of current, the amount going in must be the amount coming out. So when you look at this, if you want to find out what is the current that's flowing in this, you can either connect it before or connect it after, which doesn't matter. Okay, you'll find that the flow is the same. Or even you can connect your ammeter in between the two resistors, the current will be the same. It's because components connected in series will always have the same current. It's because they are all on the same single path of current. Again, the idea that whatever that goes in must come out the same way. So go in, come out. So all throughout this single path, the current value will be the same. What about this? If I want to find the current flowing over here, or if I want to find the current over here, where would I place the ammeter? Using a simple simulation over here, you see that we put ammeter over here, we put ammeter over here and here, in where there are two resistors and one single resistor. Okay, before I close the switch, make a prediction. What do you think would be the same current? Would this be the same as this? Or would this be the same as this? Or this and this will be the same? And so on. Think about it. I close the switch. Okay, you realize that all of them are different. This is 1.5, this is 0.5, and this is 1. Okay, you find that why is it so? It's because over here there are two resistance, so the flow will be slower. Over here there's one resistance, so the flow will be faster. But over here, why is it that it is 1.5? Is because it's a congregation of two flows. You find that the total of two flows, 0.5 and 1, would result a flow of 1.5. Okay, so that's how it works. Next, we talk about ammeter resistance. That is why the resistance of an ideal ammeter is 0 ampere. It's because you do not want to affect or change the current by adding additional resistance when you connect ammeter in series to it. Any ammeter with a large resistance is a faulty ammeter that will give you a wrong reading. Why? Let's say you're trying to measure the current that's flowing past the resistance and you add in an ammeter with a large resistance in series. Due to the increase in this resistance, let's say it is a very large R, you find that the current flowing through will be greatly reduced with the inclusion of this ammeter, and your ammeter will now read this reduced value. Your ammeter will no longer be correct, as the correct value should be the original current value before the addition of the ammeter. Remember, the ammeter is not part of the circuit and should not affect the circuit in any way by connecting to it. So, can we connect ammeter in parallel? If we remember that the ammeter should have zero resistance, we will be able to understand why ammeter should not be connected in parallel to the component. Using a simulation, okay, so this is the ammeter and this is resistor in series. Okay, and then we try to measure what is the current that's flowing through by trying to connect an ammeter in parallel. If we connect the ammeter in parallel, okay, so if we connect out the circuit, you find that the current over here flowing is 0.5 ampere. Okay, so we are trying to find out what is the current that's flowing through here by connecting in parallel, which is obviously wrong. What will happen is that if you close the switch, the zero resistance ammeter will provide a very low resistance path to the current. So noting the value 0.5, once we close it, the current actually flows through the ammeter and don't flow through the original resistance. Thus, current that flows through the component will be diverted to flow through the ammeter instead, and thus it alters the original current value flowing through the component, and ammeter will not be taking the correct reading, which originally was 0.5 and now it's changed to 1. Okay, in certain situations, it may even create a short circuit and will cause an electrical fire. So please do not connect ammeter in parallel. Okay, that's the end of today's lesson. Please subscribe and support my channel. For my other physics video lesson arranged according to topics, please visit my blog at boringphysicsteacherswordpress.com. You can subscribe to my channel to be informed when I upload new physics video lessons. Thank you.